Hello, in this video we will use matrix solution for logarithmic regression of a saturation growth model, and we will also use LINEST. Here we have a dataset where the values saturates or plateaus to closer to the value of 10. And we will show the equation of this dataset. The trend line equation will be logarithmic. And this is our equation. 6.07 plus 1.7 ln x. We will also show the r squared. So the equation is 6.07, which is our BO, plus 1.79, which is our B1, ln x. And the value of r squared is 0.951. We will calculate these values using the matrix operation and the LINEST function. We start with the transformation of our dataset, which is array formula of the y values and one column and the ln x column, which is array formula ln of the x values. So our equation is y equals b0 plus b1 ln x. In the matrix form, it will be 1 comma ln x times b0 semicolon b1. This is the 1 comma ln x, and this is the b0 b1. We will calculate these coefficients using the matrix solution and also the LINEST function. Begin with the LINEST. Now that we have transformed our dataset into the linear form, we can get the LINEST function out of this dataset. Data y and data x, and we'll show the full statistics. Our r squared is 0.951, matches to our chart equation. Our B0, 6.067, is rounded off as 6.067, rounded off 6.07. And our B1, 1.789, is rounded off as 1.79. We can also use the matrix solution for this. We begin with the Pijarina inverse, which is min inverse m multi transpose of the X matrix, the transform X matrix, and itself. And a cofactor, which is M multi transpose of the X matrix and the Y values. So now that we have this inverse and the cofactor, we can now calculate the coefficients M multi of the inverse, Pijarina inverse, and the Pijarina cofactor. Here we have B0, 6.067 matches to our LINEST output, and 1.789 matches to our LINEST output. This completes the matrix solution for logarithmic regression for saturation growth model and the use of LINEST on this dataset.